Okay, so let's talk about trig identities and their graphs. So the first thing we're going to talk about are reciprocal identities. So here's our nice unit circle. So we have our right triangle in the first quadrant, right? Just our generic right triangle. We have an x leg and a y leg, right? Horizontal and vertical, and a radius of 1, which is our hypotenuse. So we know from before that cosine is adjacent over hypotenuse, so that's x divided by 1. So cosine's x. Same thing for sine, right? Opposite over hypotenuse is y. And then tan would be opposite over adjacent, right? Which would be y over x, or divided by x. So now what if we wanted to find 1 divided by x, or 1 divided by y, right? Or x divided by y. So these are simply just reciprocals, right? And in fact, if we wanted to find any one of those three, it's just finding the reciprocal of the trig, right? So 1 over x would be 1 over cosine, right? 1 over y would be 1 over sine. And then x over y would be 1 over tan, all right? Well, we don't want to keep writing 1 over cosine, 1 over sine, 1 over tan, right? So we're going to give them their own expressions. And in fact, we're going to do SEC for cosine, 1 over cosine, CSC for 1 over sine, and COT for 1 over tan. And we pronounce these as secant, cosecant, and cotangent. All right, so these are just expressions for reciprocals of sine, cosine, and tan. And again, we have these so we don't have to keep writing 1 over every single time. All right, so those are our reciprocal identities. So in your notes, you just want to write that down. So write the way we pronounce them, secant, cosecant, cotan, and then write their equivalencies, right? So secant's 1 over cosine, cosecant's 1 over sine, and cotan's 1 over tan. The way that I remember these, secant is with an S, and it's 1 over C, so 1 over cosine. So the first letters have to be different. So as soon as I see cosecant, I know it's sine because the first letter has to be different. And then cotan and tan are easy to remember because they have the same roots. Right? Okay, so those are our reciprocals. Well, let's do our quotients. So let's get our unit triangle again. We have our right triangle again, or our unit circle again, and we have our right triangle in the first quadrant. So now we also again know that cosine theta is x, sine theta is y, and tan is y over x. Well, if we know that cosine theta is x and sine theta is y, we can make tan sine over x. So tan theta is the exact same thing as sine, well, I think I said sine over x, but tan theta is the exact same thing as sine theta over cosine theta. And the reciprocal of tan is cotan. So take the reciprocal of sine over cosine, you'll get cosine over sine. Right? So that's how we get our quotient identities. All right, so in your notes, you're going to write the quotient identities. So tan is sine over cosine, and cotan is simply just the reciprocal of tan, cosine over sine. All right, so you're going to want to stop the video and do classwork problem number 4. Yep, we're going to start with number 4, not number 1. Okay, so we talked about tan and cotan, so let's get their graphs. So I want to graph tan of theta. So first thing we know, right, from our unit circle is tan of theta is just y over x. And now let's go around the circle of the axes and see what's going on. So at 0 degrees, right, y is 0. So I'll get a 0 divided by the x value. So the tan of this should be 0. Now when I go up to 90, right, x is 0 now. So I'm going to get a y divided by 0. So when we divide by 0, remember from our asymptote lectures, this is a vertical asymptote. So I'm expecting some vertical asymptote. So I have a 0, a vertical asymptote. Here's y is 0, so I have another 0. And here's x is 0, so another vertical asymptote. So I'm expecting to see some vertical asymptotes here. And when we pop up the tan graph, that's exactly what I see. Right? At 0, the y value is 0, so it's 0. But then at 90, we divide by 0, so we have this vertical asymptote. And then 180, we're back to 0. 270, we're at the vertical asymptote because we divide by 0. And then 360, we're back to 0. And then repeat. And had I gone in the negative angle, right, that direction, I would have had the same kind of thing going on. All right, one other thing I want to note is, notice that all these tans are increasing. And then the other thing I want to note is in the first quadrant, it's a positive y and a positive x. So if I do the division of two positive numbers, I'll get all positive values. So that's why we start at 0, and you can see they're all positive, and they shoot up to this infinity. Well, when I get to the second quadrant, I'll have a positive y, but a negative x. And a positive divided by a negative will be negative. So that's why in the second quadrant, they come from infinity, and they're all negative, and then they go to 0. All right, so this graph actually shows me from 0 to 90, these are all the values in the first quadrant. 90 to 180, all the values in the second quadrant. And then 180 to 70, all the values in the third, and they're all positive. Because look at this, negative x, negative y. When I divide two negatives, it's positive. All right? So that's kind of a neat correlation between the unit circle and the actual graph. All right, let's do cotan now. Cotan is the reciprocal of sine, or tangent, so it's x divided by y. And now, let's go around the circle. So here, the y is 0, so I'll divide by 0, so I expect an asymptote at 0 degrees. Here, the x is 0, so it's 0 divided by y, I expect a 0. And then at 180, another asymptote, because the y is 0. And at 270, I expect another 0, because the x is 0. Well, let's see how that works. And you can see that's just what it is. So at 0 degrees, I get a vertical asymptote, right? Because y is 0 there, and I'm dividing by 0. And then I get a 0 at the 90 degrees, another asymptote at 180, and then another 0 at 270. Okay, now look at cotan. Cotan's always decreasing, right? Which is kind of interesting. And notice that cotan follows the same kind of sign as tan does. So 0 to 90 is the first quadrant, and even though they're decreasing, they're all positive, because it's still positive divided by positive. And then I'll have a positive y divided by negative. My second quadrant should all be negative, and you see they all are negative. And then the third quadrant are all positive, and then the fourth quadrant all negative. So in terms of which quadrants are positive and negative, the cotan and tan are all the same, right? But tangent is always increasing, cotan is always decreasing, and their asymptotes are a little different, right? They're off by 90 degrees. All right, so in your notes, you want to draw tangent and cotangent. Okay, so now stop the video. You want to complete classwork problem number 1. So we're going to start at 1 now. Okay, so let's look at cosecant. So remember, cosecant is 1 over sine. So why don't we start with the sine? So sine of theta is y in our nice unit circle. If I graph the sine function, this is what I get. We can use the same kind of logic here, right? At 0 degrees, y is 0, so that's why it's a 0. And then y is 1 here, then y is back to 0, and then y is negative 1. So that's why you can see it's 0, then y is 1, y is 0, y is negative 1. Then back to 0, and it repeats over and over and over. All right, but that's my sine. Well, we know that cosecant's 1 over sine, so cosecant's 1 over y. So it turns out anytime y is 0, I'm going to get an asymptote, a vertical asymptote. So now cosecants will also have vertical asymptotes, and specifically when the y's are 0. Well, when are the y's 0? At 0 degrees and 180. And that corresponds very nicely to my graph. See, at 180 I get a 0, at 0 I get a 0, 360 I get a 0. So as soon as my graph, or where my graph crosses the x-axis, that's where I'll have my asymptotes. So those will be vertical asymptotes. All right, so I graphed the sine. I figured out when the sine function is 0, and that will be my vertical asymptotes for my reciprocal. And then all I do is graph these kind of parabola shapes. I just follow the asymptote, I cross or I touch right at the max, and then I go back up. So I have a whole kind of grouping of these positive or up and down parabolas. All right. Okay, secant, we can do the exact same way. We know secant's 1 over cosine, cosine's x. So let's plop up a cosine graph. And now you'll see x here is 1, the next is 0, the next is negative 1, the next is 0. So that's why we have 1, 0, negative 1, 0, and so on and so on. All right. The nice thing about this is secant is 1 over x. So wherever x is 0 is where the asymptotes will be. And now the x's being 0 are 90 and 270. And it corresponds very nicely, again, with where the actual cosine graph crosses the x-axis. All right. So in both cases, where the sine and cosine graph cross the x-axis, that's where your vertical asymptotes will be, because that's where the corresponding value that's in the denominator will be 0. All right. And then just like cosecant, we just do parabola shapes, right? We follow our asymptotes, we connect to the maxes and mins, and we're good. All right, so in your notes, I want you to graph cosecant and secant. All right. Okay, so you're going to stop the video now, and you're going to complete classwork problems 2 and 3. All right, let's go on to some Pythagorean identities. So again, here's our nice unit circle. We have a right triangle. And from the Pythagorean theorem, we know that a right triangle, it's the sum of squares of the sides equals the actual square of the hypotenuse. So in our right triangle, it's x squared plus y squared equals 1 squared, which I just made 1. All right, so that's just Pythagorean theorem, straight out of right triangles. And then for the unit circle, we also know that cosine of theta is x divided by 1, which is x, and sine of theta is y divided by 1, which is y. So I actually know what x and y are in terms of cosines and sines. Well, if that's true, why don't we substitute them in? So I'll have an x squared, which will be cosine squared. Then I'll have a y squared, which will be sine squared, and it all equals 1. So I just substituted these values into the Pythagorean theorem, all right? And notice when we do cosine squared, the square goes on the s, right, over the s. That's what represents cosine squared, which is cosine times cosine. The sine, the square goes over the n, right? So we don't actually put it over the theta because that would represent theta squared. And we don't put parentheses around the whole thing because this is a shortcut. All right, but cosine squared would be cosine and then put the square on the s, and sine put the square on the n. All right, but that's our third Pythagorean identity. So this represents right here that you pick any angle you want, right? Cosine squared of 30 degrees plus sine squared of 30 degrees equals 1. Cosine squared of 111 degrees plus sine squared of 111 degrees will equal 1. So it doesn't matter what degree you pick as long as it's the same. Square them from the sine and cosine, and you always get a 1 if you add them up. All right? Okay, so that's our first big Pythagorean identity. We can actually use this Pythagorean identity to construct the two other identities. All right, so if I have cosine squared plus sine squared equals 1, I can divide everything by cosine squared, right? It's across an equal sign, so that's legitimate, right? That's a proper math step. Then you'll see cosine squared divided by cosine squared, sine squared divided by cosine squared, and 1 divided by cosine squared. Well, we know that sine divided by cosine is tan, so it turns out that sine squared divided by cosine squared is tangent squared, right? And we also know that 1 over cosine is secant. So 1 over cosine squared is secant squared. So I can actually replace those two terms with tan squared and secant squared. And we know that cosine squared divided by cosine squared is 1. So this actually rewrites into 1 plus tan squared equals secant squared. All right, so pretty clever. You just take the original Pythagorean theorem, cosine squared plus sine squared equals 1, and divide everything by cosine squared. So in essence, you really don't have to memorize cosine squared plus sine squared because you can figure this one out. And we didn't have to just divide by cosine squared. We could have done the exact same thing, but divide by sine squared. All right, so if we do this, cosine divided by sine is cotan. So cosine squared divided by sine squared is cotan squared. Sine squared plus sine, or divided by sine squared is 1, right? And then 1 over sine squared, 1 over sine is cosecant. So 1 over sine squared is cosecant squared. So I can replace those two terms with those, and I get cosine squared plus 1 equals cosine, good lord, cotan squared plus 1 equals cosecant squared. All right, so those are my 3 Pythagorean identities, right? So in your notes, you want to write those 3 down. And remember, you really only need sine squared plus cosine squared equals 1, and then you can just divide by sine squared or cosine squared and get the other 2, right? So there's no reason to memorize all of them. All right, so you want to stop the video. Actually, this is the end, but you want to complete classwork problems 5 and 6, right? But that'll be the end of this video.